We'll work this one final example and then we'll move on to the next concept. So here we have an integral where sine and cosine are both being raised to a power. Let's kind of rewrite this a little bit where it might be a little easier to see the power that cosine is being raised to. So not only does this work for positive integers, it works for negative integers, and it works for positive and negative real numbers no matter what they are. We're looking for whether one of our exponents, even one, it doesn't matter if both are, but at least one is odd. Because if one of them is odd, we can use our peel one off method. And we do have an odd exponent on our sine function. So I'm going to peel one of those off. I'm going to use the Pythagorean identity correctly to put that in terms of cosine. And then we will FOIL that out. Plus cosine to the fourth of x times cosine. I dropped my negative, didn't I? 1/2 of x sine x dx. Now I'm going to distribute everything with cosine in it. 1 times cosine to the negative 1/2 of x minus 2 cosine squared times cosine to the negative 1/2. I add the exponents, and I'm going to wind up with a positive 3/2 as a result. 2 minus 1/2 is a positive 3/2, and then plus cosine 4 minus 1/2 will give me a positive 7/2. And then there's my sine x dx. Now I'm ready for my u substitution. So I'm going to say u is positive, so cosine. So du has to be negative sine. So we're going to have, let me give me some more room here. We're going to be off by a constant, and we can write all of those cosine functions as u. And then du. So we love it when one of our exponents is odd. So let's see. 1 over 1 minus 1/2 is 1 over 1/2. So that's 2u to the 1/2 minus 2 times 3/2 plus 2/2 is 5/2. 1 over 5/2 is 2/5 plus 7/2, 9/2, 2/9, u to the 9/2 plus c. So negative 2 to the cosine of 1/2 x minus 4/5 to the cosine to the power of cosine of x to the power of 5/2 plus 2/9 times cosine of x to the power of 9/2, and that negative gets distributed all the way through, plus c. And there we have it. Now, that wasn't terribly time-consuming. There was a little bit of algebra involved in that, but you definitely could see this type of problem on the AP exam. That's not an extraordinary amount of algebra to be involved in a calculus problem. It's my argument that I really do not believe that you're going to see the other type where both your sine and your cosine are both raised to a fairly high positive even value, so that you have to do that horrible trig substitution over and over and over again. But you definitely could see a problem like this. So that finishes this lesson. Come to class next time. We'll work some homework problems on these techniques for trig integrals.